Hey guys, this is Mr. C, and in this video I'll be showing you how certain transformations of functions work, such as reflections and stretches and compressions. So first thing is I've got my little graphic organizer here, and I know it says translating functions, but it should really say transforming functions. This isn't just for absolute value, it's for all functions. And so I just, again, have absolute value in here because when I teach that unit in Algebra 1, that's where this usually starts to appear. All right, so in this video, we're going to talk about reflecting about the x-axis, which means you change the signs of all the terms in your function. When you reflect about the y-axis, you replace every x with negative x in parentheses. For a vertical stretch, you're going to multiply your function by a number bigger than 1. For a vertical compression, you're going to multiply your function by a number between 0 and 1, which is usually a proper fraction. For a horizontal stretch, you're going to replace every x with ax, where a is a proper fraction. And for a horizontal compression, you replace every x in the function with ax, where x is larger than 1. So the most challenging of these transformations is going to be their stretches and compressions. And so I have this other little handy graphic organizer that I use for absolute value when I start and then go on to quadratics. A horizontal stretch, the points are being pulled horizontally away from the y-axis, and you can clearly see that happening. It goes from here to here, so it widens. A horizontal compression, the points are being pushed horizontally toward the y-axis, and so it's being compressed towards the y-axis. For a vertical stretch, the points are being pulled vertically away from the x-axis. So we see this function here being pulled, and it's being stretched in a vertical direction. So when it's stretched vertically, it's not being stretched from the y-axis, it's being stretched from the x-axis. And for a vertical compression, the points are being pushed vertically toward the x-axis. And so in this case, this one is being flattened out and the points are being pushed towards this x-axis right here. And it's going to depend on whether or not your a value is a proper fraction or it is larger than 1 to determine whether it's going to be a stretch or a compression. And so we will talk about those things as we go. And we've got some examples for you. And we're going to start out with some reflections. So the first one says the function f of x is equal to the square root of x. Again, not necessary to know all about square root functions at this point. We just need to know how to write the new function, reflected across the x-axis to form the new function. So from the first graphic organizer, when it says reflect across the x-axis, the instructions were to change the signs of all the terms. And so simply all you have to do is take g of x, and in this case, there's only one term here, the square root of x. You just make it negative square root of x. And if you change that, that should reflect it across the x-axis. So I have my handy Desmos here, and hopefully you guys can see that. And so if we take Desmos and we graph the square root of x, okay, we see that we get the red curve. And then if we, on the second one, take the negative of that, we do see that we reflected across the x-axis, and so we get this other part down here. And so it happened exactly the way it was supposed to. All right, so now let's clear those out. Let's take a look at this one. This one says the function f of x is equal to x squared is reflected across the y-axis. Write the new function. So we have g of x is equal to, and so what's it say to do for reflections across the y-axis? It says to replace every x with negative x. So if you take that x right there and replace it with negative x, what happens? Well, that is correct. That is what you're supposed to do. However, for this problem, when you square a negative 1, because this is really negative 1 times x squared, when you square these, the negative 1 is going to basically go away, and you're just going to get x squared back for that one. And so if we take, again, our Desmos, and we put in x squared, so x squared, we see that we get our parabola. But if we take this And I'm just going to show you for an example. A lot of students might do this right here. Now that's going to be wrong because that negative is not in parentheses right there. It's outside the parentheses. And what that did was that reflected it across the x-axis. But we don't want that. What we want is instead, let's get rid of that. We want parenthesis, negative x. And then we're going to close parenthesis, and then we're going to square it. And we see now that the two graphs overlap. And so we were correct about that. Now, is that going to happen every time? Absolutely not. It happened this time because this graph right here is already on the y-axis, and when you flip it on that y-axis, since the vertex is already there, it's just basically going to flip onto itself. All right, so you're not going to worry about that at all for this one. But other ones, like lines and such, you know, those will, or if you move it left or right first, those will have a completely different graph when you apply the y-axis reflection. All right. So let's get rid of those. Okay, on to our next one. Okay, this time we're going to vertically stretch this function by a factor of 2, okay? So we're going to take absolute value of x. Now, a vertical stretch is supposed to multiply the function by a number bigger than 1. And so that 2 should go outside of those absolute value bars. So g of x should be equal to 2 times x, like that on the outside. Because for a vertical stretch, that's what it basically says to do, multiply that function by that number. All right, so let's check this one out and see if we're right. Okay, so let's see where absolute value is. Okay, there's absolute value of x, our classic V shape. Okay, we take it now and we multiply it by 2. And what do we get? So we see that the graph kind of went like this. It pushed it towards the y-axis. So in our definition of a vertical stretch, it said the points are being pulled vertically away from the x-axis for a vertical stretch. So did that happen? Yeah, they're being definitely pulled away from the x-axis. They're actually being pulled towards it. And so if you zoom in on it a little bit though, you see for this particular example, because we're at the origin, we stay at the origin for this one. But if it had been pulled down or up, then that could look a lot different. So let's get rid of those. All right, so there's a vertical stretch. Okay, now we have a horizontal stretch, factor of 1/2. Okay, horizontal stretch says that we're supposed to replace every x with ax, where a is a proper fraction. So what we're supposed to do is take f of x and change it into g of x equals. We need to replace that x with this times this 1/2 x. Now that is just a line. And so again, the parentheses like we saw before are just going to go away, and our g of x for this problem is going to be 1/2 x. Okay, so now the definition of horizontal stretch was the points are being pulled horizontally away from the y-axis. So let's verify that that did happen. Okay, so here's our classic identity function x. Okay, there it is. And now we're going to do 1/2 x. And so if you do 1 divided by 2, I love Desmos, puts into a fraction, I arrow over, put my x on there. And is that what happened? Are the points being pulled horizontally away from the y-axis? And it looks like they are, because the slope has actually gotten smaller here, and the line is being pulled away from the y-axis, and it's actually being pulled, you know, it looks like it's closer towards the x-axis, but that's by definition a horizontal stretch, and that's what it should look like. All right, so let's clear those out. Let's see. Okay, now let's take a look at our next one. And again, these are very basic, just because we're getting started with this. We'll do some other ones later. Okay, we got the function. It's a parabola, x squared, quadratic, being vertically compressed by a factor of 1/3. All right, vertical compression says that we have to multiply the function by that number right there, that proper fraction. The definition of vertical compression is the points are being pushed vertically toward the x-axis. So we need to see if that's actually going to happen. So if we write this, g of x is equal to, and the graphic organizer said for vertical compression, we're going to multiply the function by that 1/3. Okay. Now let's see what happened was supposed to happen. So now here's our classic parabola, x squared. And I need to, let's see, let's home that. Okay. And so now we've got 1/3, so 1 divided by 3. Okay, arrow over, x squared. Okay, so vertical compression, again, the points are being pushed vertically toward the x-axis. Is that what happened? And it looks like they are. The points are being pushed vertically towards that x-axis, and so that is a correct graph. And so I know my function now looks good. All right, let's clear those on out. Love Desmos. Desmos is free. It's on the internet for free, but on a device, to me, it just works so much better. Okay, so here we go for this one. Let's change colors. The function f of x is equal to square root of x is horizontally compressed by a factor of 3. I want you to look and see what that graph looks like here. So horizontally compressed by a factor of 3. So let's talk about that. Horizontally compressed, you're going to replace every x with ax. And so a is bigger than 1. So it says that we're supposed to do this. G of x is equal to, you're going to replace that x with the square root of 3x. All right, that's what it says to do. And so now the explanation of horizontal compression is the points are being pushed horizontally toward the y-axis. All right, so let's see if that happened here with this one. Okay, so we've got square root x. That's our parent function, and that's exactly what it looks like. Kind of looks like half of a parabola that's been twisted over this way. Kind of think about it that way. Now, let's do the square root of 3x, okay? And here's what was supposed to happen again. The points are being pushed horizontally toward the y-axis. Is what happening? Yes. The points are being pushed horizontally towards the y-axis. We can see that when we compare the two graphs. As a matter of fact, let's make that number a little bit bigger this time. Let's make it a 10 and see what happens. So make it a 10, and you can now see definitely that graph is being pushed horizontally towards the y-axis. If you make that number bigger, let's do 100, 100x, you know, and then we're getting really close to that y-axis there, and you can clearly see from those 4 graphs what is happening with that. All right, so it looks good, and Desmos, always a good thing to use. That kind of concludes this little introduction to these transformations. In the next video, we're going to talk about sequences, and that should be a lot more fun. So remember to like and share, subscribe to my channel if you haven't already, and we'll see you guys later. Bye.